We now move on to metamorphic rocks. Metamorphic rocks are formed when pre-existing rocks are subjected to increased temperatures and/or pressure. The combination of these factors causes the minerals to recrystallize without melting, forming new minerals and textures. Here's a brief explanation of the processes involved in the formation of metamorphic rocks. Number 1, heat. Increased temperature is one of the main agents of metamorphism. When rocks are subjected to high temperatures, the minerals within them become unstable and may start to break down. Over time, these minerals may recombine to form new minerals with different chemical compositions and crystal structures. Number 2, pressure. Increased pressure is another agent of metamorphism. When rocks are subjected to high pressure, their grains may become tightly packed together, causing recrystallization to occur. The direction of the pressure may also cause new minerals to grow in a specific pattern, creating new textures such as foliation. Number 3, fluids. Fluids such as water or other fluids can also play a role in metamorphism. Fluids can help to transport ions between minerals, causing chemical reactions and new mineral growth. They can also contribute to the removal or addition of elements from the rock, changing its composition. The type of metamorphic rock that forms depends on the degree of heat and pressure applied, as well as other factors such as the presence of fluids. Metamorphic rocks can have diagnostic textures that provide clues about their formation and the conditions they experience during metamorphism. Number 1, contact metamorphism. Contact metamorphism occurs when rocks are heated due to contact with magma or lava. When hot magma or lava comes into contact with cooler rocks, it can transfer heat to the surrounding rocks, causing them to be heated and undergo contact metamorphism. The heat causes the minerals in the rock to recrystallize, forming new minerals and changing the texture and structure of the rock. This process can also cause the rock to become harder and more resistant to weathering and erosion. Contact metamorphism typically occurs in areas where there are igneous intrusions, such as around the edges of plutons or along the contact between lava flows and sedimentary rocks. Number 2, regional metamorphism. Regional metamorphism occurs when rocks are subjected to high pressure and temperature over a large area, often due to tectonic activity. This process can occur when two tectonic plates collide, causing rocks to be squeezed and deformed. The pressure causes the minerals in the rock to recrystallize, once again forming new minerals and changing the texture and structure of the rock. The temperature also plays a role, as it can cause chemical reactions to occur between the minerals in the rock. Regional metamorphism typically occurs in areas where there is mountain building activity, such as at convergent plate boundaries where two tectonic plates collide. In summary, contact metamorphism occurs when rocks are heated due to contact with magma or lava, while regional metamorphism occurs when rocks are subjected to high pressure and temperature over a large area due to tectonic activity. Both processes cause the minerals in the rock to recrystallize and form new minerals, changing the texture and structure of the rock. Let's look at textures. Number 1, a non-foliated texture. This texture is found in metamorphic rocks that do not show a parallel arrangement of minerals known as foliation. Non-foliated rocks may have a fine-grained texture with small crystals or a coarse-grained texture with larger crystals. Marble, which forms from the contact metamorphism of limestone, is an example of a non-foliated rock. Marble typically has a fine-grained, equicrystalline texture with small crystals of calcite. Metaquartzite forms from the contact metamorphism of quartz sandstone that typically has a fine to medium-grained, sugary texture. It is characterized by interlocking quartz grains that are well cemented and have recrystallized to form a hard, dense rock. Number 2, a foliated texture. This texture is found in metamorphic rocks that have a parallel arrangement of minerals known as foliation. Foliation is caused by the alignment of minerals in response to directed pressure, which influences crystal growth during metamorphism. There are different types of foliation textures, including slaty cleavage. This is a smooth, flat surface that develops in fine-grained, clay-rich rocks, such as shale or mudstone. During metamorphism, the minerals in the rock become aligned along cleavage planes, resulting in a parallel arrangement of platy minerals that are perpendicular to the direction of pressure. Slaty cleavage is commonly found in rocks that have been metamorphosed under low to moderate pressure and temperature conditions, such as slate. Schistosity. This texture is characterized by a coarser-grained, platy or elongated mineral arrangement, with minerals such as mica aligned perpendicular to the direction of pressure. Schistosity develops in rocks that have been subjected to higher pressure and temperature conditions than those that form slaty cleavage. The resulting minerals in the rocks are larger and more visible, giving the rock a distinctive striped appearance. Schist is an example of a rock with a texture called a schistosity. Gneissic banding. This texture is characterized by alternating bands of light and dark minerals with a coarser texture than schist. Gneissic banding develops in rocks that have been subjected to high pressure and temperature conditions, resulting in the segregation of minerals into light and dark mineral bands. Gneiss is an example of a rock with gneissic banding. Some metamorphic rocks can be the product of both contact and regional metamorphism, as in the case of marble and metaquartzite. Metamorphic rocks, such as schist, marble, and metaquartzite, have diagnostic mineralogy that can be used to identify them. Schist is a metamorphic rock that is characterized by its visible parallel layered structure called foliation. The minerals that make up schist are typically micas such as biotite and muscovite, as well as minerals such as quartz and feldspar. These minerals give schist its characteristic shiny reflective appearance and its ability to split into thin, wavy layers. And this picture is of a quartz schist. Marble, on the other hand, is a metamorphic rock that is composed primarily of calcite. Marble is formed from the metamorphism of limestone, which is a sedimentary rock composed of calcium carbonate. Marble has a characteristic white or light-coloured appearance and will effervesce with dilute hydrochloric acid, giving off carbon dioxide gas. Metaquartzite is a metamorphic rock that is composed of primarily quartz. Quartz is a hard, durable mineral that is resistant to weathering and erosion, which gives metaquartzite its characteristic durability and hardness. Metaquartzite is typically light-coloured, has a crystalline appearance, and does not effervesce with dilute hydrochloric acid.